Welcome back to the second part of the video. Now we're going to look at a different scenario. So all of the rational functions that we've looked at, the polynomial were unique in the sense that there were no common factors. Now let's look at this scenario where p of x and q of x have a common factor in them. Normally what you would do is you would cancel them out, right? But once you cancel them out, what is the meaning of that? So let's look at an example over here. If I have f of x equal to x squared, that's not x squared, but x plus 1 squared and x minus 1 divided by x plus 1 and x plus 2. You can clearly see that there is a common factor. I got x plus 1, x plus 1, and then I have x plus 1. I can divide this divides itself out, and they cancel out. But in canceling, something just happened. If you pick that expression alone, it says that x cannot be equal to what? Equal to -1. So when we cancel common factor, that means we cannot divide by 0. When x is equal to -1, this expression here becomes 0 over 0. We cannot divide by 0, and so by canceling that common factor, we say that the graph has a hole at that x. So in this case, I have a hole at x equal to 1. Well, what's going to happen is if we cancel this out, now this expression now looks f of x is equal to x plus 1, x minus 1 all over x plus 2, and we need to qualify this that x cannot be, oh, I believe this is supposed to be -1, my bad, -1. All right, we know that x cannot be -1 when we do this. So this becomes the expression that we want to work with right now. Okay, so that is the whole idea about a hole in a function, in a rational function. When you have a common factor and you cancel it out, since it's a rational expression and it's undefined because you're doing 0 over 0, we say that we have a hole at that factor. So it's x minus x plus 1. That x equal to -1 becomes what we call a hole at that location. And you're going to show that when you graph it with an open circle to show that you have a hole in that function. So let's look at some examples over here that they have. So if you look at the first one, if you simplify this, you get x minus 3 all over x minus 3. So we're able to cancel that common factor, telling us that we have a hole at x equal to 3, and the function now is 1 over x, where x cannot be what? Cannot be 3. All right, if we look at the second example, you have x cubed minus 2x squared all over x minus 2. You are able to factor out an x squared. You get x minus 2, and then you get x minus 2. So you have a common factor that cancels out. We end up with just x squared, where x cannot be what? 2. That's where you have a hole. All right. So the question is, how does that look like when you graph it? So if you look at the example that they have over here, we discovered that after canceling the common factor, we had 1 over x, where x cannot be 3. So we know the graph of what? 1 over x, which is what they have over there. They've sketched it. But then we need to locate where that hole is. And remember that for every graph, we need to know x and y. So how do we find the x and the y? So you just need to plug in that x value into the function. So if I plug in f of 3, it tells me on the 1 over x graph, it's at what? 1/3. So I need to go locate that graph, that when I get to, when I sketch that graph, when I reach 3, you know what I mean, right? I got a hole right at this location over here, and then I can continue sketching my graph. All right, so to find the y value of the hole, you need to plug it into the refined or the simplified function so that you're able to find where the location of that hole is. Okay, if you look at the second one, that function simplified out just to be x squared, where x cannot be -2. So you can draw the parabola. However, you need to locate where that hole is. So if you plug in t of 2, you end up getting 4. So you go to 2 and then locate 4, and then you can locate your hole right over there. Okay, so then when you talk about range and domain, you're able to kind of describe what the range, the domain looks like, and what the range looks like. Okay, so this is an example of where you have common factors, and when you have common factors, you end up with a hole in the problem set, in the graph when you sketch it. Okay, all right, so that is it. In my next video, I'm going to do 2 examples where you have holes and how you sketch them. Okay, alrighty, cool. Thank you for watching.